Very good morning to one and all present here. Today I'm going to discuss about the heat exchanger. Okay, so before going to the heat exchanger, we should know what is a heat exchanger. And before going for the heat exchanger, we should know what is a heat transfer. So, how will you define the heat transfer? The transfer of heat from high temperature to low temperature with the modes of conduction, convection, and radiation. And the equipment used for the heat transfer is a heat exchanger. So, this is the basic definition for the heat exchanger. Uh, The next is the a small introduction about a heat exchanger. So as we discussed about the heat exchanger, a heat exchanger is a system used to transfer a heat between the source and a working fluid. Heat exchangers are used in both cooling and heating process. The fluids may be separated by a solid wall to prevent mixing, or they may be in direct contact. So the main applications of the heat transfer or main application of the heat exchanger is it will be used in your space heating, refrigeration, air conditioning, power station, chemical plant, petrochemical plant, petroleum refineries, natural gas processing, and sewage treatment. The classical example of a heat exchanger is found in an internal combustion engine in which a circulating fluid flows as an engine coolant, which flows through a radiator coil and an air flows past the coil, which will be used as a coolant and heats the incoming air. And another example we have found that about the heat sink, which is a passive heat source that transfers the heat generated by an electronic or device to a fluid medium, often air or liquid coolant. So this is a general introduction about a heat exchanger. Uh, then when we go for the heat exchanger, the main parameter is about the flow arrangement. So we'll be having a three types of flow in which they will be having the classified as a parallel flow, counter flow, and cross flow. So in a parallel flow, the hot fluid and the cold fluid enters at the same direction, and while it's in counter flow, the hot fluid and the cold fluid flows in an opposite direction. And in the cross flow, the hot fluid and cold fluid flows in the perpendicular directions. In most simple system, this is the LMTD. We call it as an LMTD. The full definition of the LMTD is the log mean temperature difference. So this method is used for finding out the average mean temperature. So this is a basic diagram of the types of the flow as we discussed earlier in the previous slide. So this is a parallel flow and counter flow. So as I discussed about the parallel flow, your hot fluid and the cold fluid will flow in the same direction. So this line indicates your the hot fluid, and this line indicates about the cold fluid, the inlet and outlet. So the arrow mark indicates the same direction. That's why we call it as a parallel flow. When we go for the counter flow, see the arrows will be in the opposite direction. Okay, so the hot fluid and the cold fluid will flows in the opposite direction. So this is your arrow and this is the arrow. So these both of our arrows are on opposite direction. So we call it as a counter flow. So these both, and one will be the cross flow, that will be the perpendicular for the hot fluid and the cold fluid. And these flows are very important while we go for a heat exchanger. While you're going for a design of a heat exchanger, you have to be well aware about which type of flow is used in the problem. And the next, the main important topic is the types of an heat exchanger. So shell and tube heat exchanger, plate type heat exchanger, plate and shell, adiabatic wheel, plate fin tube, pillow plate, kettles, reboilers, and condensers. And today I'm just going to mainly focus upon the shell and tube heat exchanger and double pipe heat exchanger. Okay, so the first one will be shell and tube heat exchanger. The shell and tube, see, so this is the construction. The mainly will be having a shell inlet, shell outlet, tube outlet, and tube inlet, and will be baffles, which consist of the number of tubes. So just remember one thing: the line which this is a line. This is not a tube. This is a shell, and the between these shells, this is a tube. So this is the tubes. So we call it as this is the tubes, and this is the shell. The outer part we call it as shell, and baffles. So baffles, we know actually what is the main purpose of the baffles is to increase the heat transfer coefficient one, and second one will be it will support the tubes. So this is the main constructions of the mainly consists of the shell and tube heat exchanger. Okay, so baffles. Hope we have all seen about our home. So we'll be having a grinder for mixing. Okay, so in the grinder we'll be having a white color plate that will be the baffles. So why we use the baffles in the grinder for mixing your rice and your dal. Okay, so if the grinder is if the plate in the grinder is not present, what will be happen? Your raw material which is present in the grinder will not be mixing efficiently. So for that, we are placing the baffles in the grinder. Similarly, we are placing the baffles in the heat exchanger for increase the heat transfer coefficient. So what happens will be the hot fluid will flows in the shell or tube, and the cold fluid will flows in the opposite. So suppose examine that this will be then countercurrent direction. So what happens is that when the hot fluid flows inside the tube and the cold fluid will be outside the tube. So what happens? The first of all, your tube will get heated. So this tube, so this surface of the tube will get heated through the modes of the conduction. So we know the what is the conduction. So based upon your atoms, the heat will be transformed from high temperature to low temperature. So first, what happens there? The surface of this tube will get heated, and after getting this, the fluid which is placed inside the tube will be get heated through the convection. So just mainly note this: when we go for the shell and tube heat exchanger, the conduction and convection both will take place inside your shell and tube heat exchanger. See, I am repeating again. See, when the hot fluid and the cold fluid is placed inside the shell and tube heat exchanger, the surface of the tube will get heated through the conduction. And after the heating of the surface, the fluid will get heated through the modes of the convection. So this is the main concept for the shell and tube. And you see the flow. The what will be happen? The shell inlet will go through this, and it will be touching with the baffles. Then it will be moved through the upwards, then this direction, and then this direction, and then again this direction. So it means that if we are not placing the baffles between the tubes, what will be happen? Your hot fluid and cold fluid will be flow in this direction. So there will be no heat transfer, there will be no conduction, there will be no convection, and what will be happen? Your efficiency will be very very less. So that's why we are placing the baffles inside the tube. So as we discussed about, the main purpose of the baffle is to increase the heat transfer coefficient and to support the tubes. So that's why we are placing the baffles like this. See. So this is the placement of the baffle. It will support the tubes for creating a contact between your hot fluid and the cold fluid. So this is the main working of a shell and tube heat exchanger. So the main modes will be both the conduction and the convection will plays a vital role in your heat transfer in your shell and tube heat exchanger. If your surface gets heated, this will be the conduction, because as we know that the conduction will take place at the solid surfaces, and with the help of the fluid movement, the heat will be transferred. That will be because of your convection. So this is a general construction and working of your shell and tube heat exchanger. So what are the main parts of the shell and tube heat exchanger? Will be a shell, tube, tube sheet, shell and shell side nozzles, tube side nozzles, and baffles. So we have been discussed about this in briefly. So this is the number of passes. So the diagram which I showed in the previous slide, which is that it will be a one pass. So it means that we'll be having one shell and two tubes, and this is the two passes. Say this is the two passes. So what will be happen because of these two passes means there will be a two shells and number of tubes. So we call as an 1, 2, 2, 4. That will be so two shell, four tubes. That will describe your 2, 4 passes. And here we'll be having four. So four shells. This two and this will be the two. So this is the number of passes based upon your heat exchangers equipments. And this is the general, what are the tubes length, shell diameters. So heat exchanger with shell diameters of 10 to more than 100 inch, typically manufactured by standards we call as an TEMA. So the TEMA means as you all know, Tubular Exchangers Manufacturer Association. So based upon this only, we can decide we have to take out the length or we have to take out the diameters of the tube. So generally we will be using the 0.65 to 1.5. So this is the main inch, pipe or inch. And the main material which is going to manufacture for the tubes will be the low carbon steel, copper, nickel, stainless steel, and called titanium or other materials. And tubes are either drawn and seamless or welded. High quality electro resistance welded tubes exhibit good grain structure at the weld. Extruded tube with the low fins and interior rifling is specified for certain applications. So this is a general description of the tubes. Then tube sheet. For before going to the tube sheet, I will be showing you the diagram of the tube sheet. So this is the tube sheet. So this is the tube sheet diagram. So this is the tube which will be surrounded by the sheet that we called as a tube sheet. So this is the general a tube sheet, and this is a general the assembly of the shell as we discussed discussed about the shell is an outer part of the tube. So this will be either from a pipe up to 24 inch or rolled and welded plate metal. For reasons of economy, low carbon steel is common in use, but other materials suitable for extreme temperature or corrosion resistance often are specified. So if we want for the low type of heat exchanger or low budget of heat exchanger, we can go for the carbon steel. But the main disadvantage of the using of the carbon steel, it cannot withstand your corrosion or temperature resistance. And using commonly available shell pipe to 24 inch diameter result in reduced cost and case of manufacturing, partially because they generally are more perfectly round than rolled and welded shell. Then roundness and consistent shell inner diameter are necessary to minimize the space between the baffle outside the edge and the shell, as excessive space allows fluid bypass and reduce the performance. In extreme cases, the shell can be cast and then bored to the inner diameter. And this is the shell assembly. See, we'll be having a nozzle inlet as I shown in your diagrams, and this is impingement plane, then tube blank. So this is a tube. So this the zigzag, the cross like this, no. So this will be the tube. We call it as a tube. Then baffles. So as I discussed about in the diagram, what will be used over? First of all, we use the baffles for support the tubes, and then it will increase your heat transfer rate or heat transfer coefficient. Okay, so a baffle must have a slightly smaller inside diameter than the shell inside diameter to allow assembly, but it must be close enough to avoid the sustainable performance penalty caused by the fluid bypass and baffles. So in this construction, you have to be well aware, well known about that a baffle must have slightly smaller inside diameter than the shell inside diameter to allow the assembly. If you have the large baffle compared with your tube or compared with your shell, what will be happen? You cannot fit your baffle inside your shell and tube, or if you cannot place your baffle inside your heat exchanger. So the conditions for fitting your baffle should have a slightly smaller inside diameter than the shell inside diameter. Then only you can fit the baffle inside your shell and tube. And this is an applications of shell and tube. So power generation, HVAC. The full form of HVAC means heating, ventilation, and air conditioning. Marine applications, pulp and paper, refrigeration used in your pharmaceutical, air processing, and metals and mining, and many more. So these are the main applications of shell and tube. That's why I've just given to you. So the next heat exchanger will be on double pipe heat exchanger. So this will be your schematic diagram of a double pipe heat exchanger. So what will be happen? We'll be having a larger pipe. So this will be your larger pipe and this will be your smaller pipe. So will be the same construction. So we'll be having a hot fluid inlet and cold fluid inlet and hot fluid outlet and a cold fluid outlet. So this will be your bend. It will be like an U shape. So this will be like an U shape which will be connected with your both of the pipes. So double pipe heat exchanger is a device that provides a transfer of thermal energy between the two fluids at a different temperature. So this will be the main definition of your heat exchanger. So you can define your heat exchanger as a device that provides the transfer of thermal energy between the two fluids at different temperatures. The major use of these heat exchanger is a sensible heating or cooling process of the fluid where small heat transfer occurs. So when we compare your shell and tube and double pipe, the main use of a double pipe is you can use the double pipe heat exchanger where you need the less heat transfer area. So it means that if you have the less heat transfer area, you can go for the double pipe heat exchanger. If you need for more heat transfer area, you can go for the shell and tube heat exchanger. The best example for this double pipe is the oil cooler process. So in double pipe heat exchanger, we have a large pipe with a small pipe inside it concentrically, and all the heat transfer process occurs inside your larger pipe. So one fluid flows to the inner of the small pipe, and another flow like between the two pipes. The outside or shell side includes the fluid flow passing on the inner side or tube side. So this type of heat exchanger is known as a hairpin. So as I've shown in the diagram, that U shape is called as a hairpin. Jacketed pipe, jacketed U tube, and a pipe in a pipe exchanger. So the diameter will be less than 200 mm. You have to use the diameter of the pipe less than the 200 mm to. So that's then only you can increase your heat transfer rate, heat transfer coefficient. So this is the main application of a double pipe heat exchanger. The boilers, compressors, cooling and heating process in engineering systems, petroleum refinery, refrigeration, and sewage treatment. So the mainly we will be using the double pipe heat exchanger in your sewage treatment because it will cost very less amount compared to your shell and tube heat exchanger. So this is the advantage of double pipe heat exchanger. You can provide a good efficiency with low capital cost. If you need the very low capital, if you want to install your exchanger with a low profit or with a low budget, you can go for the double pipe heat exchanger, which will give you the good efficiency, and it will be compared to the shell and tube. They do not need much space. So as we discussed about that, it includes only in small heat transfer area. So as they are very popular, all the parts have been standardized and it makes the repair and maintenance very easy. So they will be having a flexible design, other addition and removal parts can be done easily. You can use this type of heat exchanger at high pressure and high temperature. So the design of the heat allows more thermal without any expansion joint. And if we have some advantages, definitely we should have some disadvantages also. So these are the disadvantages. So they are usually used in counterflow design that cannot be used in some application. And it does not mean that they cannot be used in parallel flow. So what is the meaning of this line mean? We can use this type of heat exchanger in a counterflow mainly. But when we go for the parallel flow, it is best suitable to use your shell and tube heat exchanger. So they have the limitation in heat transfer rather than the complicated designs and should be used in low heat duties. So leaking is more often in this type. And this is the characteristics of double pipe heat exchanger. It is made up of a concentric pipe that are connected by the mechanical closures. They are particularly tailored to high temperature, high pressure. They are inexpensive, durable, and easy to maintain. And the building of the double pipe heat exchanger is a straightforward.